What I'm going to try here today is look at an Atwood machine. And the reason why I'm looking at an Atwood machine is it's helpful to look at absolute dependent motion. Also throws in a tiny bit on relative motion. This is a compound Atwood machine. So you have a mass at A that's hooked up to another mass that's really a pulley plus a second set of masses B and C. The pulleys have centers at E and at D. And you're asked to find what the velocity of A is and the acceleration of A. Let's start to write some equations. So we have length of A, we have length of B, we have length of C, and we have length of B. And I'm using a B1, C1 so I don't confuse myself too much. I should have probably used L's. So I can write that XA plus XD is equal to a constant. Because this green line plus this green line is not going to change in total length. It'll be XA plus the wraparound length plus D. That is the total length of the chord. The second chord is going to be XB plus this wraparound length plus this, LC. So in total length, both of those equal constants. And I can draw up some kinematic relationship. So I can say, well, if XA plus XD is equal to a constant, then when I take the derivative, this goes away. And so XA dot XD dot is VA plus VD equals 0. XA double dot, XD double dot is acceleration of A plus acceleration of D. I get into a slightly more difficult problem when I look at B and C. So X dot B and X dot C is over here. And when I do that, I have those equal to 0. But this point D is moving. And I've got it over here and over here. So A and D equations are velocity of the blocks, A and D, and they move with respect to the non-translating point. So these move with respect to point D, a moving point. XB1 is equal to XD plus XB. XC1 is equal to XD plus XC, because I've got to consider that it already has some sort of velocity, either upward or downward, depending on the motion of A. I solve for all those terms, and I get the velocity equations right here, and I get the accelerations. This is just a useful example to show this type of absolute motion. It doesn't do very much more than that, and it's designed to sort of highlight dealing with what I would say is again, the first part for A and D, relatively simple, B and C, much more complex.